All right, yeah, there we go. All right, hello everyone. My name is Myrick. So I'm from Expedia Group, and today I'm going to be talking about how we went from a previous REST API model to a federated GraphQL model. Hello? Good. Yeah, so today we've already heard about some of the new methods that Apollo is building for federated GraphQL and some of the tooling. This has actually been our journey through the initial kind of concept of GraphQL and what we previously heard of as schema stitching. This is kind of the journey and what we've learned over the past year or so doing GraphQL and how we're going to be working towards this new federated model. But just heads up, this is not the federated model you saw earlier today. So just to start off, you might have heard I said Expedia Group. Expedia Group is actually a collection of 25 different brands. And I work for specifically these brands and the group of Expedia Group. And we, over the years of our companies, we've built lots of different technology to provide products to our customers. So things like hotels, cars, flights, activities, etc. And all these different products are managed by different teams. Those teams can be all across the globe. We have offices here in Seattle, offices in London, Chicago, India, Brisbane. And so a lot of these teams all have to work together. And that can be sometimes very difficult. Sharing across time zones, doing remote meetings, communication across these different boundaries and culture differences can kind of lead to just different ways on how we develop our products. So we were noticing some discrepancies when we kind of started looking back at what we were building for our customers today. So we actually first started our GraphQL journey by looking at our traveler experience. So if I'm someone coming to one of our brands, like let's say Expedia, I'm going to possibly want to book a hotel and a flight to a new destination. Maybe in that destination I'm going to use some activities. So here is just some general screenshots of what search results might look like on all those different product pages. You might notice they look similar-ish, right? They're all using kind of the same colors. They're displayed in a list. But really, if we kind of break down to some of these details, there's just things that are different that really don't need to be. And if we want to provide a consistent experience to our customers, we want everything to look the same and make sure everyone's seeing the same information. So things like the filters and sort selection, right? In one page, you might be at the top, and you might have an optional input bar where you could add more information, versus like on our mobile app, they're down at the bottom. You have to press a button to open up a new page. And sure, that's fine, right? It's different experiences, different teams building the apps. But really, that's leading to an experience where the traveler is using the UI in a different model on one page and then transitioning to buying a different product. They're still on the same site, but now they have to use it in a different manner. And that just kind of leads to a jarring experience. But not only is the UI different, sometimes our data would be different. So we have right here on the left side, there's this little module which tells you if you're booking a hotel in Maui, we know the inventory for that region on the dates you're searching, and maybe it's really sold up, right? It's 99% booked, so you might want to consider booking a hotel. That API is provided by a specific team. They might have REST API and documentation that you have to use. And this other team who maybe is using a different page, maybe they're not even consuming that API because they don't know that team exists. So overall, you might even get different experiences on the data that you show your customers. So this is what we really wanted to change. If we wanted to align our traveler experience, we needed to first make sure that we're showing the same data to all our customers. All right, so how do we kind of get to that separated experience? Well, like with most companies, we have a lot of domain teams here at the bottom. We have our hotels, flights, cars, all the themes I mentioned before, and they provide a set of APIs. And it's not just a single API. The hotels API team that provides lots of different APIs to provide the shopping experience to our customers. And they have to somehow connect to all the clients here up at the top. So we have our web clients. There might be the desktop and the mobile web. We have our iOS native applications, maybe even some new clients going forward like Alexa and chatbots. And so they have to, of course, they have to connect to all these different services. So as a client, if I know I need to provide some new product to our customers, our travelers, I have to first know that this product even exists in our company. Like I said, right, that API that provides the booking availability, I might not even know as a client team that someone actually made that API in Expedia because we're a fairly large company. But let's say I do know this team exists, they're making this API. then I have to go talk with that team. I have to possibly say the amount of traffic I'm going to be sending this team so they can provide appropriate scaling. I have to read their documentation. I have to understand how their REST API works. Where I need to provide certain keys. And you just have to do all this back and forth communication before you even start thinking about sending a sample request or even using their data. But then, no, other than that, on the domain side, on the bottom side of the API team, you also have to manage all the different clients, right? So let's say you have all your client lists out there. Let's say you want to deprecate a field or deprecate an API, right? You have to then send out these mass emails to every single client saying, hey, we're going to turn this off on 2 weeks. Hard deadline, better migrate. Of course, we reach that 2 weeks, no one's migrated, so we just got to keep sending out these emails over and over again, right? So it's just kind of hard to have this back and forth communication. And then that just scales even exponentially when, again, we're talking about not just teams working in possibly the same office, but we're talking about teams working across the globe and across different time zones. So we kind of started to reduce our concepts here, or reduce the kind of friction, the interaction points we had when we started moving to a PWA, which is a progressive web application, and a BFF, which is a backend for front end. This was kind of one of our first goals. The main goal here was to reduce the amount of client code that the PWA has, so that it also reduces the amount of business logic it has. Right, so if we want to move all the business logic back to the server, that means we can consolidate all the connections coming out of the BFF. It can handle doing all that data connection, bringing up the appropriate data to the client, and then the client can just be worried about displaying the data in a view-specific manner, and it reduces all the logic, reduces the client payload, and makes the app faster for everyone. And this went great. We learned a lot from implementing this pattern. We are actually going to be, we really believe that the PWA is a good pattern going forward. But if we wanted to roll this out for any of the other applications, not just maybe on the lodging, but the flights team, or even on iOS or Android, we realized we had to do a BFF for every single application because they were all just slightly different. And if we're just adding another BFF for every single service, that really isn't solving anything. Now we're just having another layer in between the different data connections. So what we really needed was a BFF for every single service, a BFF for everyone. So this is where GraphQL comes in. Right, we've all kind of heard the story of how GraphQL can unify our schema, and we have one single schema now served to the clients. The clients don't have to worry about where the data is coming from or setting up these connections. Once you kind of get onboarded, you do that initial setup of connecting to the graph, then you just write your queries and you don't have to worry about that communication back and forth between the teams. And this is exactly what we wanted to do. However, as I mentioned before, the hotel's domain team is a large organization. They have tons of APIs, lots of developers contributing. I looked at just the contributors of the BFF, for the lodging BFFs the other day. We had over 150 contributors to that code base. So that's a lot of people for just one section of this little graph. Right? So if we wanted to scale this out to everyone, we couldn't have every single team contributing to one single GraphQL codebase or API or schema. So we know right from the start, we actually had to kind of come up with this concept of federated schema, which means that we actually let the individual domain teams create their own GraphQL services. So hotels can own the service that provides the data for hotels and the landing search pages that you might see. And then customer team can provide all the customer data you need, or maybe the checkout team can provide all the checkout data that you might need. And then it's up to the top-level gateway to then just stitch those all together into one top-level schema that the clients interact with. So now we have the benefit of clients interacting with just a single interaction point, but the teams themselves can still be isolated and kind of focus on their areas or their domain that they really understand. And this has just been kind of the goal of how we've been going forward is making sure that all these teams can provide these new GraphQL microservices in a quick manner, because we were currently on the REST architecture. So how do we migrate from REST to getting all these teams to create these microservices? Well, we needed to kind of have some technology changes, right? So first off, we needed to kind of work with our teams with our existing technology stacks that we had. So a lot of those API teams, they're using Java and lots of platform libraries, which are Expedia specific. So we needed to still integrate with those teams. So that means we need to do GraphQL servers in Java. We also needed to kind of talk with the teams that they were doing, because a lot of the teams, since they were isolated, they could do stuff on their own. They were building their server technologies differently. So some teams were using Spring Boot, some teams were using Drop Wizard, some teams were logging their metrics in Splunk, some teams were logging their metrics in CloudWatch, or just anywhere where you might have your metrics library. Teams are doing it differently. And we wanted teams to kind of make sure if they're getting on board to this GraphQL platform, they're all doing it similar. Which means that we need to kind of start changing the developer experience. So we first start off looking at, okay, if we want to do a GraphQL Java server, we looked into the GraphQL Java open source library. It's a great library maintained by a great community. It's very active. However, we noticed that we wanted to add some more features on top of that server implementation. We really enjoy using Kotlin at Expedia. It provides some great developer tooling. The language is really rich, and it has this great feature of nullability. So in Kotlin, you can say something is null, or it might not be, or it is nullable or is non-nullable. Same thing with GraphQL. And so we knew that that we could use these tools together to kind of provide some new schema generation for a GraphQL Java server, which I'll talk about in a little bit. So not only on top of that, if we're going to be building this server with all these different tools, we wanted teams to be able to easily onboard onto this GraphQL architecture. And if they wanted to create that little GraphQL service in between the clients and the gateway and their existing API, they needed to quickly be able to spin up a new GraphQL service. So we started standardizing some of the metrics, some of the logging, some of the server technologies, and we just provide a template for our teams to kind of fork that template, and then from there they can easily just add their business logic, and then their schema can then be exposed up into the graph. And now, since we're all using the same technology, we all get the same metrics, we can kind of coordinate with teams better, and we have an SDK which everyone kind of consumes, so if we need to roll out new GraphQL features or tools, everyone can just update their SDK version, and we can now coordinate with all these teams managing both the servers and at the gateway level as well. And then also we needed to kind of standardize some of the tools we're doing around our schema stitching. So right now we have, before we were doing our first pass at GraphQL, we just kind of took the schema, we just started with one hotel schema, and we provided it up to the Loom, and it just kind of exposed the schema. But we realized that if we wanted to provide more tools for the developer experience to catch any schema breakages, anything that might go wrong, making sure that you're stitching the schema properly, or you're not adding a field which might cause some errors, we need to also kind of standardize the developer experience for schema stitching as well as you're doing your server development. So first off, let's kind of talk about the generating that schema. So we actually open sourced the GraphQL Kotlin, which is an extended, just an extension on top of GraphQL Java. So if you're using GraphQL Java today, what you can do is if you are coding that server in Kotlin, instead of writing a schema file, which you traditionally write a separate GraphQL schema file, or maybe just writing it in a string format, you can instead just write your Kotlin code as if it's a function. So you write a function like get hotels, and that might accept some optional arguments, and then returns a Kotlin data model. And that, all we do is we just use reflection, looking at that function, that turns into a GraphQL schema. It is called it's called by the same field, it returns the same object types, and just allows our developers to not worry about maintaining two sources of truth of the schema file and your code. You can just write your function, which is your Kotlin function, and that's your schema. It just makes it a lot easier to kind of go back and forth. So if you want to check us out on GitHub, GraphQL Kotlin and up there on GitHub. And then also, since we have this SDK and we have all these different services and everyone's using the same domain types, we wanted to make sure that if, let's say the hotels team, since we're doing schema stitching, they added a new type and they called it coordinates, right? Coordinates are pretty common as far as travel goes, right? We needed to know where a specific point is on the globe. So coordinates might have a latitude and longitude. Well, if we're doing schema stitching, if the hotels team added that into their schema, that would actually conflict if the flights team wanted to add it into their schema, because we don't know which one is the source of truth, right? They would actually conflict in the schema stitcher, which means we needed to have some way of sharing types across the different services. So in our SDK, we actually have this concept of a shared type. It's just simply marked with a little directive @shared. Really, it's just an information marker in the schema. But this just is actually code that's checked into our SDK, which then all the schema developers can use. It provides some consistency, so we all are using the same information. So we did this with some pretty core concepts like coordinates, geopoints, regions, things like that. We also did it for things in our UI. So rather than just returning a datetime object, we have a datetime object which has a localized string. So you can always, everyone's going to see the same format for a date. So you're no longer going to see a date in, month, day, year on one page, and it might be year first on the other page. Everyone's going to have the consistent date formatting on the same pages. Same thing goes with currency, right? Like, do we round the currency to the nearest cent, or do we round to the nearest dollar, right? That type of business logic shouldn't be determined by each individual team. It should really just be something kind of company-wide, unless there's some specific reason why it needs to be different, right? But if we had a company-wide decision, that means we all get the same formatting, we all get the same experience across our different travelers. So speaking of the stitching, let's say we have these shared types. The first thing that we did to kind of implement the schema stitching of getting the schema back into the gateway was that we had all of this, we have all our services here. So we have the GraphQL gateway and we have individual services. The first approach we had was just to write a simple polling code. We put this code in the gateway, and what it would do is the individual GraphQL services would expose an endpoint, which exposed the schema. So we could just hit that endpoint and say, hey, give us your latest schema. What's your schema right now? And we just ran that on a polling operation, and we'd update if we noticed there was any changes. We just update the GraphQL gateway schema, and we just expose that as the new master schema. This obviously didn't work too well, because sometimes what if the polling operation had some errors, maybe teams deployed something that they weren't supposed to. We kind of quickly realized that this was not the best model going forward. So our V2 for schema stitching kind of looks a little something like this now. So let's say we have the flight service here. They make a change. We do our checks on the change, and let's say it gets merged in. So what happens is that schema actually gets generated on build time before the app was deployed, and we push that up to a S3 bucket, so it's just somewhere it's stored. And then what we have is actually a AWS Lambda, which is watching all these storage locations for all the different schemas, and whenever something is modified, then that stitcher can run the same code which we previously had in our gateway. We move that out of the gateway, and now it can run the same code to stitch the schema together, do any extra validations, and then push that up to the gateway. So not only does it just push it to the gateway, but we actually push it to another S3 bucket, which is now our history of the public schema. So since we kind of moved this process into our build pipeline, we can now add more extra metadata around our schema. So we can now say, okay, this is the Git hash. That's how we actually tag the version that is currently deployed. But we can add Expedia-specific information, like what was the SDK version used to build this schema? What was the logging libraries they were using? Anything we can just kind of keep track of more metadata, since it's now being published into our own repository of our schema registry. And not only that, since we're now kind of putting it into the pipeline, we started pushing our tools into the Apollo schema registry. So this is where we started connecting with the Apollo team and kind of talking about how we were doing federation and what their plans were for the schema registry and their federation going forward. And we started using some of their tools. So as we saw earlier, since we're pushing the schema into a registry, we can now look at the types in a nice UI. So using Apollo Engine, which I guess is now called Graph Manager. And then not only that do we have the schema registry, but we have the usage information, right? So now we can see that the clients here, the number of clients using the specific field on a property, like the ID, image, name, but also the operations they're performing. So if we need to talk with a specific client because they are using a deprecated field, we can see exactly that client that's using that operation, where it's coming from, and what kind of data they're sending us. So if we have this registry of this information, we can now actually validate the schema changes, right? So we can look at the usages. Someone's made a change. We can run a GitHub check on PR time to validate that, hey, your schema change, which you might have not known you made because all you did was write a simple Kotlin function, you might have actually broken the schema. This kind of has been really, really helpful for us, because because we made the developer experience of creating a schema so easy, often as we were training new developers, they didn't realize that just adding a new field into a Kotlin data class actually impacted the end result of the schema. So now we can validate this on PR time and kind of push these changes lower in the stack and catch them earlier. All right, so now we have all these great technology changes. We needed to start rolling them out to the other teams. And you can't just do this by saying, here's the tools, go ahead, have fun. We needed to actually start training teams and talking about what GraphQL means and how you use these tools. And this kind of requires more of a personal connection, culture changes in our company, which people are not used to, right? We're not used to having to work in a single graph. We're used to having our own teams work in their silos, they make their API, they have full control. But now, if we're working in a single graph, we actually have to talk with each other. We have to sit down and say, like, why does this data need to exist in our graph? What business value are you providing? And so we needed to maintain our graph in some way. And we noticed that we couldn't just let the teams contribute to the graph as they see fit. We needed to have some responsibility of what actually went into the graph. And so we first started with this concept of a schema manager, which is, or schema managers, and the core team for GraphQL. And that's actually the team that I work on. So we kind of are the team that coordinates between all the different teams providing GraphQL services, and we bring them together to make sure that they are all understanding of how we want to do GraphQL, because you can do GraphQL in lots of different ways at your company, but the way that we want to implement GraphQL. And we want to make sure everyone's doing the same thing, using all our tools that we provided, whether that's in the SDK or in all our development tools, and making sure that we coordinate together. So now that if we're actually bringing teams together, we can now have meetings where previously the hotels team and the flights team would never talk to each other. There's no reason for them to talk. But now if they're actually coming into a single graph, now we can actually talk about things that might be doing similar that they never even realized. And we can start sharing code, sharing ideas, and it's just been a really big shift in the way that our teams communicate. Now that we're, again, spread across the globe, it's kind of been a big culture shift for everyone to kind of get used to. So we wanted to define some of those best practices, like what does a good GraphQL schema look like for us at Expedia? And for us, the first thing we want to do is write all these rules down. As the schema managers, we could tell everyone these, but again, since we're a global company, we needed to make sure that all this information was written somewhere. Teams could come back to it and reference it as they see please. But if not only that, if we decided to change our decisions or change our understanding of what a good schema looks like, we could then go update the documentation. And it just comes to be a central place for everyone to kind of coordinate. We also needed to do schema reviews with the teams, right? So I mentioned before that we'd have a meeting to kind of bring the teams together. What often occurs is that we have teams, they propose a new a field that they want to add into the schema. Usually it's a top-level field, something like that we want to add new capability, they want to do the property search, the hotel search in the GraphQL API rather than a REST API. Well, what we would do is we actually sit down with that hotels team and we'd ask them, hey, what does your schema look like for property search? Are you actually returning the best schema possible? Let's look at like what you're returning, let's look at your data models, and let's discuss if this is the best approach. And this is not just like, we're not trying to be gatekeepers here, we're not trying to block people from doing development, but it's just a good way to make sure that if we're trying to roll this out across multiple teams, multiple organizations, that everyone kind of really understood what good GraphQL looks like for us. So we actually sit down, we have these reviews, and then we keep iterating to make sure that you're not just blocked, but we can provide the best schema possible for your customers. And not only that, we wanted to make sure that the schema would just evolve. So if you're not locked into providing a single schema right now, we want to make sure that the schema you're trying to provide for, let's say, property search again, it could be extendable to some new features down the road. And so a schema which is scalable for us is actually a schema that is designed for the clients. So I mentioned earlier that we wanted the UI to look very similar. Well, that means that the clients should actually be kind of defining the schema based on the UI, right? If we have our data models, they should not be focused on defining the concept of an API. They should be focused on powering the clients that we need to actually show. So for us, we want to actually focus on the client defining their schema first, right? If your client understands the responsibility of all the business value it needs to provide, all the use cases it has. It actually understands kind of the edge cases that you might have not known because maybe previously the client was calling 2 APIs and merging the data together, and you didn't even know that as the other API team. So we actually first start with the client, and then we work backwards from there. We started talking with the service team saying, okay, this is the client, this is the schema that the client wanted to implement. So how can we work with those service teams to now adapt the schema to fit that client need? And then we also want to make sure that any data that we added is only ever going to be used by the client. So we wanted to align on the data that we're showing the customer, but we're also trying to slowly align our visual elements at Expedia. So if one customer, let's say it's the mobile app, the iOS app, if it's using data that's different than the Android app, that right there, that's a red flag for us, right? We don't want clients using different applications. So we actually want to make sure that all the data we're adding is going to be used by similar applications. And if data is not going to be used, it shouldn't really just go in the graph at all. So let's kind of take a look at what designing an API might look like, or designing a GraphQL schema might look like if we instead start from the API. So up here, we have first chunk. Again, hopefully everyone can see that. Basically up there, all it is the first part of JSON. It says the user object, and it has some flag saying, is the user logged in? Right? Let's say you called the API to check if the user is logged in, true or false. And then we have another concept here. We get a list of hotels, and every hotel has this concept of member pricing. Right? You don't need to know what that is. I'm just telling you that it exists. But let's say as the API team, that's all you know too, right? You just know there's this concept of member pricing. So what we're going to do is if someone's logged in and they are a member, then we're going to show this new feature on our hotel search results. Okay, sounds great. So if we go over here to the right side, you might see we have a new field, hotel search. We can get a list of hotels, and every hotel has an ID, name, and this new flag, which is display the member pricing, right? So it's just pretty simple check. Now the client doesn't have to do that 2 check for is the user logged in or not. They just have 1 single check, which is user logged in, or display the member pricing, true or false, just show it onto the user. Seems pretty simple enough. But if we actually kind of take a step back and actually look at this, the client experience and what they develop, they actually have 2 things they might show the customer. So up at the top there is the badge for the member pricing, right? So if you're logged in, you might see this little badge saying, hey, if you're logged in, you get to save more money. But the client knows that actually it displays this other information in that same location, which is maybe a shortage. So this hotel, there's only 8 rooms left, so we're going to give you a special deal on that hotel if you book now, right? But only the client knows right now in this situation which order that displays. What if we had both features enabled, what if both were true, right? Which one goes first, which one takes priority? If that logic is coded into the client, that's business logic, then it has to be duplicated across every single client consuming that graph, right? So iOS, Android, all the web apps, everyone has to add that same Boolean check. So instead, what we try to do is have a schema which just provides information that the client needs, which really all you see here is the concept of a badge, right, an offer badge. And all it has is possibly an icon and some text that is going to display to the user, right? And this is actually what is being powered by the client. And yes, this might be a very specific UI example that not everyone might use in their GraphQL API, but really the core concept here is that we're trying to reduce the client logic, right? Any Boolean checks that your clients do, any enum checks, any filtering that the client is doing, if you want to test those changes out across different apps and services, you then have to go to every single client and app to make sure that they're all doing the new business logic. Whereas on this model, we can actually try maybe a new badge, right? And the client doesn't even have to know if the badge changes at all. On the back end, we can run a new test, maybe 10% of the traffic see this new concept, the new badge with a different color, right? We can test out on the back end which one is better, but we don't have to update the clients. So this is kind of the design of a client-first schema. All right, so just to kind of wrap up here, the lessons we've learning over kind of implementing all these changes is that we want to first reduce the developer friction, right? The GraphQL is really not about the customer experience. Our travelers don't care if we're using REST APIs, they don't care if we're using GraphQL APIs. All they see is a product, right? They just want to be able to book a hotel, book a flight. So the GraphQL is really meant to empower your developers to make sure that your tooling works for you, that you are getting all these safety checks. And if your developers are working faster, working better, that actually then translates to your customers seeing benefit, providing more features to your customers. All right, so making sure that the developer friction for us has been key for all this entire migration. And then having our client-first schema, which what we learned from implementing a PWA first, has really been paying off, right? We've been trying to teach this model to more and more teams as we onboard them onto the GraphQL architecture. And sometimes it takes teams a little bit to kind of understand what we mean by client-first, but eventually it clicks, and we have been seeing these benefits of being able to run TNLs on the server and not being worried about updating clients, and it's actually really paying off for our business. And then secondly, or just kind of last point here, creating a community, creating this like idea of like maintaining a GraphQL schema at a large company is very hard. Just creating a community in general is very hard, right? So the idea of having a schema manager team is that we start kind of bringing more teams into this concept of what does our GraphQL schema and what does good GraphQL look like. If we can teach that to more and more teams, it no longer becomes the responsibility of just the core schema managers team to enforce that. It becomes the collection of everyone who's using the GraphQL schema to actually benefit from having a good schema, right? Not just the servers, but also the client developers. We all want to create the best experience for all of us. So, and last point here is just we kind of now have transitioned into thinking no longer in terms of APIs, but we now think of GraphQL as a graph for our business. Right, we think of all our different clients here are just experiences and how we show some data. The data just comes from a graph, and it's up to the platform, the graph platform to provide all these answers to questions that all these applications might have, like what are the nearest hotels near the Space Needle? Can I put that hotel in my cart? What are the reviews for that hotel? And are there insurance options for that hotel? All these are just questions that our customers are asking to us, and it's up to the graph to answer them. And then if we need to change any architecture or APIs under the hood, the graph doesn't care, right? The clients don't need to care about that. All right, so that's all I have for today. If you want to follow us on Expedia Group, we're hopefully going to be posting more publicly about kind of how we use Apollo Federation going forward and we migrate to the new Federation model. You can also follow me social, and here's some of the links for today. Thanks, everyone.